folks, this evening we've got some great matchups. We've got 3 matches going on tonight. We're going to have some good, exciting action on today's functions. We're going to start off with a match with linear versus non-linear. And then we're going from function to versus not a function. And moving on to continuous versus discrete. We're going to be followed by a commentary on how to describe today's functions. Let's get ready to rumble. All right, let's start with linear versus non-linear. We start off with this graph here. Here's the XY coordinates. We have a graph. There is my graph. Is that linear or non-linear? Well, let's see. Does it form a straight line? Yes. We have one for linear. Next, we have another graph. Looks like this. Is that linear or non-linear? That's a curve. It's not going to form a straight line. That is a non-linear. We have one for the non-linear there. One more graph. Here we go. We got another graph here. Looks a little bit like this. Is that linear or non-linear? Well, although they do form straight lines, there is this sudden turn here. So this is a non-linear graph. All right, let's go on to equations in here. If we've got y equals 2x plus 1, is that a linear equation or a non-linear equation? Well, whenever you have a variable without an exponent on it, and there's no absolute values, if you just got a number times it, plus it, even fractions in there, you're okay. That's a linear function. You graph that line, you graph that equation, you're going to form a straight line. So yes, we have a linear function. What about this one? If we have y equals 2/3 x plus 5, is that a linear function? Yes. No exponent on the x, no absolute values, no square roots, nothing like that. We're just multiplying the x by something and then adding something. It is a linear function, so another one for linear. Next equation, we have y equals x squared plus 2. Is that a linear function? Well, that's an exponent. So no, it's not linear. We have another non-linear. We have a tie game right now. Let's bring in the heavy hitters. We have y equals 1 over x. That's a tough one. Here we're dividing by x. We may have to graph to see if this one is. We're going to have to go with a graph on this one. We're going to have to go with a graph. So we're going to plug in some values. If I plug in 1 for x, I get 1. Plug in 1 for x, I get 1 for y. So 1 is going to be like that right there. When I plug in 2 for x, I get 1/2. So at 2 for x, I'm coming down a little bit right about there. When I plug in 3 for x, I get 1/3. I'm coming down a little bit closer to the line there. What if I plug in 100? I get 1 over 100. Have I hit the 0 line yet? No, at 100, I'm going to keep getting closer and closer and closer to that line there. So this graph is going to go, and as it turns out, it's going to go up like this too. Is that linear? No, it's got a curve to it. So we have non-linear is the winner at 4-2-3. All right, moving on to our next match. Our next match, we have function versus not a function. All right, let's take a look. Remember, in order to be a function, for every input, there needs to be one and only one output for it. All right, so let's see here. If we have a graph that looks like this, is it a function or is it not a function? Well, let's remember, the input values are the x values, which means for every x value, there should be only one y value, because the y values are the output values. How can I test this graph to see if it's a function? Well, there's something called the pencil test. That's where you take out a pencil, or a pen in this case, put it down, and as you move along the graph here, moving it along the x-axis, but holding it perpendicular to it, you should hit the graph at only one point along that line. And when I do that, I'm hitting it here, 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 here. I'm only hitting it at one point for every x value. I'm hitting that graph only once. It's a function. In fact, every linear function is a function, except when you have one that goes straight up and down like that. Because when it goes straight up and down like that, when I put my pencil there, I hit every point on that line. Which means every one of those is the same output for the one input. Not good. Not a function. All right. Let's take a look at another graph. An upside down parabola. Is that a function or not a function? Well, when we put the pencil down, we move along here. With the parabola, these things will continue to get wider and wider and wider apart. You're never actually going to hit that graph more than once when you draw a vertical line through it. So yes, it is a function. All right, moving on to the next one. What if we have the parabola like this? Well, if I draw a line like this through here, I'm going to be hitting the function twice, which makes it not a function. All right, now, if I go have a graph like this, where I have points, is this a function or not a function? All right, well, as you go along, I'm going to hit this point, I'm going to hit that point, I'm going to hit this point. Do I ever hit 2 points with it? No. For every input value, there's only one output value. So it is a function. All right, what about points? We could actually be given relations as points. 1, 2, 1, 3, 1, 4. These are 3 points on a coordinate plane. Though they form, well, as a relation, they are a relation. Does it form a function? Well, the output of 1 can be both 2, 3, and 4. That one input has 3 different outputs. Not a function. So that's 2 not functions. Let's try another one. What if we have, let's see here, 1, 2, 2, 3, 3, 4. Those 3 points, do they form a function? Well, for the input value of 1, we only have the output of 2. For the input value of 2, we have the output value of 3. For the input of 3, we have 4. There's no repeats in the x. If you have no repeats in the x value, you have a function. So yes, there is the function. We're now 4 to 2. Let's change this graph just slightly. Let's put another point right here. Is it still a function? No, it's not. We got a straight line here that will go through 2 points, this point and this point. So now it's no longer a function. But function is still ahead, 4 to 3. And we're going to end the match there. All right, good job, functions. Now we're going on to continuous versus discrete. Continuous versus discrete. Continuous functions. From any point to another point in the graph, every point in between is going to be included. So every single point, even whether no matter how small or how big the fraction or number, every point in between will be included. So the question is that a continuous or discrete function? Well, every point along the line, whenever you've got the continuous line like this line that keeps moving like that, it makes it a continuous function. So yes, it is a continuous function. All right, let's try another graph. Let's say we've got this point, and this point, and this point, and that point. Is that a function? Yes. Is it a continuous function? Well, starts here and then kind of jumps over to here, and jumps over here, and jumps over. there's no connection between those points, it is not a continuous function. So that is a discrete function. All right, what about this one? I got a line here, and a line here, and a line here, and a line up here. Well, we do have lines in it. And lines are a part of the continuous. But there's a disconnect here, and another disconnect here, and another big disconnect between these. So it is a discrete function. All right, what about a line like this? Is it discrete or continuous? As soon as I put those arrowheads on there, it's definitely continuous. We have a tie between continuous and discrete, and we're going to leave it like that. Moving on to tonight's discussions of describe the function. Hello, folks. Now that we've had our exciting events of this evening, let's take a moment to describe the functions that we may have seen today. This here is an upside-down parabola. It's going to have a square in its equation. And we need to describe it using one of the many terms we just learned in today's matches. Well, we do have a continuous line, so it is a continuous function. Is it a function? Well, yes. We've learned that before. Remember, when we draw the lines through, we're only going to hit once, so it is indeed a function. Is it linear or nonlinear? Well, it doesn't form a line. It's got a curve. So it is a nonlinear continuous function, or continuous nonlinear function. They're not really picky about the order on that. I know I'm not. All right, let's look at this one. Is it a function? Well, you draw lines through here. You're only going to hit these points once. So yes, it is a function. Is it linear? Well, they do form a line. They're not connected to form a line, but they do all fall in one line. So yes, it is linear. So we have a linear function. But is it discrete or continuous? That's right, it is discrete. Over here, as you're going down the points, if you put a pencil on the table here, oh, wait a minute, you see that? These two points have the same x value. If they have the same x value, it means this is not a function. So we cannot give it any further description. You might say it's discrete because there's definitely no line through the thing, but it's not a function. Here, is this a function? Well, put the pencil test down, you go through here, you're going to hit the point, hit a point, hit a point, hit a point. You only get 1 point for every x value, so yes, it is a function. Is it linear? Well, now we got that V shape going on there. With that V shape, it means it is not linear. So we have a discrete, because there's no lines, discrete, non-linear function. Thanks for playing with us today. Hope to see you in class tomorrow. Thank you.